whenever we are talking about the relative stability of free radical, always there are tertiary free radical is more stable than secondary free radical and then primary free radical. If you are talking about the relative reactivity in halogenation like this one, when methane in the presence of sunlight are just heated through thermal reaction, just abstraction of this through homolysis, we need 104 kilocalorie per mole, that is methane. But when we are talking about ethane, the energy required for ethane free radical is del H 98 kilocalorie per mole, right? But when we are talking about propane, there are two types of carbon. One is primary carbon and another is secondary carbon. In other words, there is one is primary protons and another is secondary protons. So free radical formation in propane is 98. If a proton homolysis of primary proton is 98 kilocalorie per mole, while the secondary proton or secondary free radical formation at 95 kilocalorie per mole, right? So much easily as compared to this primary one. If we are comparing this tertiary free radical, formation of tertiary free radical, the extraction of proton through homolysis that require energy is 92 kilocalorie per mole. So we can easily understand that tertiary free radical form easily than secondary free radical. There is less energy required as compared to primary free radical, right? And in primary free radical, again, methane is methyl free radical require more energy than ethane free radical, right? Because ethane free radical is more stable than methane free radical. So when we are talking about these four concepts, these four important concepts, relative reactivity in halogenation, or if you are talking about the stability of free radicals, if you are talking about the ease of formation of free radical, or if we are talking about the ease of extraction of hydrogens from related carbon, so the order of reactivity or stability or ease of formation or ease of extraction of proton is always like this way. That is, tertiary one is more stable, tertiary free radical is more stable than secondary free radical, and the secondary free radical is more stable than primary free radical. And if you are talking about the extraction of protons, tertiary proton easily extracted in photochemical reaction and thermal reactions, then secondary proton, then primary proton. And if you are talking about the free radical formation, ease of formation of free radical, tertiary free radical easily formed as compared to secondary free radical, and secondary free radical is easily formed than primary free radical. And if you are talking about the stability of free radicals, tertiary free radical is more stable than secondary free radical, and secondary free radical is more stable than primary free radical, and so on. And if you are talking about the relative reactivity of in halogenation, again, the tertiary free radical is more reactive than secondary free radical, and secondary free radical is more stable than primary free radical. So this is a common phenomena or common order of free radicals. The tertiary one is more stable than secondary, than primary, and so on. So this is all about free radical reactions of alkane, right? If you have any question related to these, you can ask.